Hello and welcome to our series of mathematics lessons. We are continuing to look at the topic indices and surds. During our previous lesson, we made an introduction on indices and surds, where we gave out the subtopics that are supposed to be covered in this topic, and we also discussed the first subtopic, which was on index notation. We said that indices are normally noted using bases, or what we call or termed factors, and their powers. So that, for instance, if you have 5 raised to the power of 2, this is an index where 5 is our base, or what we call the factor, and 2 is called the power or the exponent. We're able to look at several factors that surround numbers being written in the index form. That is how we can be able to write a number in expanded form. This 5 raised to 2, for example, in expanded form, we are having 5 which is repeated twice. So that means we shall be having 5 multiplied by 5. It has been repeated twice, which will give us, if evaluated, to be 25. We were able also to look at the prime factorization, where in prime factorization we say that if you are given a number like 48 and you write it in its prime factors, then 48 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2, which of course this will result to 16. Then we multiply that by 3 to give us 48. So in index form, or this one written is in index form, shall be 2, which is the factor, multiplied by 3, which is another factor or another base. Then we are having 2 repeated 4 times, so that means we raise 2 to 4. 3 has been raised or has not been repeated, or we just have 1. So we have that. So this means that written in index form, and the prime factorization of 48 shall be 2 raised to 4 multiplied by 3. So we want to proceed and look at the laws that are in application whenever we are dividing or whenever we are multiplying indices. Let us make a consideration. We want to multiply a to the power of m and a to the power of n. In an expanded form, because we do not know how many m factors of a are there, we don't know how many n factors of a are there, then we can come up with the first 3 multiplied by so many other factors multiplied by a, and we term these ones as the m factors of a. We are multiplying this with n factors of a, so we shall have the first 3 factors of n factors of a multiplied by other so many of them times a. So from here up to there, these are the n factors of a. Now, if at the end of the day, if you'll be having all those number of s, then for you to be able to get the correct answer for the value of m times n, that means you are going to add those particular powers or all these s, and this will give us a raised to m plus n powers of m. And therefore, we can be able to say that the total number of factors of a is m plus n, which has given us a raised to m plus n. So what does it, this one gives us or develops the first rule whenever we are multiplying factors which have the powers m and n. The next case on division, we want to consider again m factors of a and n factors of n. So let's consider a case where you have a raised to the power of m divided by a raised to the power of n. Now in this case, we are going to have many factors of a which are m divided by other so many factors of a which are n. So this one written in expanded form shall be a, we shall have the first three, then multiplied by so many others a, multiplied by an a, then we are dividing by, so these are the m factors of a. We divide by the n factors of a. Again, there are so many. There are so many of them. So you'll discover that this one, they'll be carrying out cancellation effect, and therefore for you to get the total number of s that will be remaining, then you have to subtract the n powers of a from the m powers or factors of m, and this will give us a raised to m subtract n, meaning that the total number of factors of a will be m subtract n, and this gives us the law that we normally apply whenever we are dividing indices. So let us have the two rules. Index law for multiplication. Shall be where you are given a raised to m times a raised to n, we are saying the result is going to be a raised to the sum of the powers, which is m plus n. So when multiplying, when multiplying terms with the same base, we add or refine the sum of the powers or the exponents. So that is 1. 2. Index, that is index law. Index law for division. We are saying that if you have a raised to m, we divide by a raised to n, we subtract the powers meaning we shall have raised to m subtract n. That means that when we are dividing terms with same factors, the terms with the same factor, we subtract, or we find this, the difference. We subtract the powers or the given exponents. We want to consider a number of examples on how we can be able to use these two rules. For multiplication, we have said we add the powers. Then for division, we have said you subtract the powers. Example 1, simplify giving your answer in index form. Part A, we have 3 raised to 6 multiplied by 3 raised to 4, and B, we have 7 raised to 9 divided by 7 raised to 5. So these two are questions which are in the expanded form. We are supposed to simplify them, and we give our answers in index form. Now we had said that when multiplying numbers that have got the same power, the same bases or the same factors, we add the powers. So the power of the first 3 is 6. The power of the second factor, which is again 3, is 4. Therefore, for us to be able to get the value or the answer, we write down the factor, then we add the powers, which is 6 plus 4. And this will give us 3 raised to the power of 10. The question requires us to leave our answer at that stage, that is in the index form. For division, the same thing is going to happen. We are having 7 raised to power 9 divided by 7 raised to the power of 5. Again, the bases are the same. The rule here is division, and therefore the power, the law that we are going to use whenever we are dividing bases or factors which are the same, then we are going to subtract. So this, we write down the factor, which is common. Then the powers, we find the difference, that is 9 subtract 5. 9 subtract 5 will give us 4, and therefore the answer would be 7 raised to the power of 4. Example 2, simplify each of the following using law of multiplication. 1, we have x raised to the power of 4 multiplied by x raised to the power of 5. Number B, we have x cubed y, x cubed y raised to power 4 multiplied by x raised to power 2 y raised to power 1. Then finally we have 3 m raised to the power of 4 multiplied by 2m raised to the power of 5. We are supposed to simplify each of these using the law of multiplication. And we understand the law of multiplication says that whenever you have a raised to m multiplied by a raised to n, then the result you add the powers, or you get the sum of the powers. So the first one, in solving the first one, the bases are the same. We have the first power of the first factor is 4. We add it to the power of the other factor, which is 5. So in index form, this shall be x raised to the power of 9. For the second case, we have x raised to the power of 3, y raised to the power of 4, multiplied by x power 2, y. Again, realize that here we have got two factors. We have the factors of x, and we have got the factors of y. So we can begin by writing down those two factors. Then, because it's multiplication, we are going to add the powers. So for the first one, it is x power 3, x power 2. So we add the powers, 3 plus 2. Then for y, this is like y has been raised to the power of 1. Therefore, for us to get y power 4 multiplied by y power 1, we are going to add the powers, which will give us 4 plus 1. So when we simplify this, this shall give us x raised to the power of 3 plus 2, which will give us 5. Then y, 4 plus 1 is 5. So the answer will be x raised to the power of 5, y raised to the power of 5 in index form. On the last question here, we have 3m raised to the power of 4 multiplied by 2m raised to the power of 5. Again, for us to be able to solve this, you'll discover that we have got these two constants, which is 3 by 2. We can begin by writing them. Then m, we have this factor of m. The first one raised to 4, the other one raised to 5. We are going to add, because of multiplication law, that will be 4 plus 5. So when we simplify, 3 multiplied by 2 shall give us 6. Then m, 4 plus 5 will give us 9. So this will be the answer when you have simplified. So always recall that for multiplication, then whenever you have a raised to m multiplied by a raised to n, the result we add the powers raised to m plus n. Example 3, simplify each of the following. Using law of division. Number 1, we have 10, x raised to the power of 10 divided by x raised to power 2. Then part B, we have part 8, a raised to 6, b cubed divided by 12, a squared, b squared. So we are supposed to solve this one using the law of division. We understand that whenever we have equal bases, then we're going to have a raised to m divided by a raised to n, since the bases are the same, then for us to be able to find the correct response to this, we get the difference of the powers, which will give us a raised to m minus n. That is the law for division. So for the first one, solving the first one, the bases are the same. So that is x, and because it is division, we get the difference of the powers. That means we are going to have 10 minus 2, which will give us 10 raised to the power of 8. For this other case, we are having 8, a raised to 6, b raised to 3, then which is being divided by 12a squared, b squared. So the factors here, these are constants, 8 over 12. So I can begin by writing that. Then we have got the factors a and the factors b. A is a raised to power 6 is being divided by a raised to power 2. So we get the difference of the powers. This shall be 6 subtract 2. Then for b, powers of 3, b raised to power 3 is being divided by b raised to power 2. So we get the difference between 3 and 2. So that shall be 3 minus 2. So when we simplify this, 4 there, 2, 4 there, thrice. So we shall have 2 thirds, a raised to 6 subtract 2 is 4, b 3 minus 2 is 1. So that will be the correct response. Let us look at a case where we combine the two. That is, we combine the index law for multiplication and the index law for division. So we are told simplify each of the following. Simplify each of the following using the index laws. Using the index laws of multiplication and division. Number 1, we have x power 2 multiplied by x power 3 divided by x power 4. Then part B, we have 2a cubed b times 8a squared b cubed, all of this divided by 4a raised to power 4 b raised to power 2. We are supposed to now combine the two laws of both multiplication and division in solving this particular question. So I'll begin with the first one. So always recall that the law for multiplication says that if you have a raised to m multiplied by a raised to n, then the result will be a raised to the sum of the powers. Then for division law, a raised to the power of n divided by a raised to the power of n, we get the difference of the powers, which shall be a raised to m minus n. So here we first look at this. So these two, we shall have to apply the law of multiplication or the index law of multiplication. And because the bases are the same, we're going to add the powers. So this shall be x raised to 2 plus 3. We are dividing it with x raised to the power of 4. This will give us x raised to the power of 5 divided by x raised to the power of 4. And then because we are now dividing, and the bases are the same, then we are going to get the difference of the powers, which will give us x raised to 1, which is simply x. Number B, we have the numerator and the denominator, where the numerator requires us to apply the multiplication index law. And as you can be able to see, we have these two constants, 2 and 8, so we multiply them first. So this will give us 2 times 8. Then we have got the factors a and b. The first one, a has been raised to 3, a has been raised to 2. So using the multiplication index law, we add the powers, so that will be 3 plus 2. Then for b, this is like b raised to 1, this is b raised to 3, that will be 1 plus 3. Then we are dividing this by 4 a raised to 4, b raised to 2. So when we make simplification of the numerator, 2 by 8, we are going to get 16. A raised to 3 plus 2 is 5. B raised to 1 plus 3 is 4. All this divided by 4, a raised to 4, b raised to 2. Then finally, you can be able to see that 16 divided by 4 is 4. Then we are dividing a power 5 by a power 4, so we subtract the powers, a raised to 5, subtract 4. Then b, we are dividing b raised to 4 by b raised to 2. That means we subtract their powers, 4 minus 2. This will result to 4. 5 minus 4 is 1, so that will be 4a. 4 minus 2 is 2. So the correct answer for our part B shall be 4ab squared. So let's consider other examples that are having combined, that requires you to combine the two laws. Simplify the following. A, we have 9m raised to the power of 5 n raised to the power of 2 times 4 mn cubed, all this divided by 12 mn times m power 4 n power 2, all this multiplied by m cubed n raised to 2 divided by 2m squared n. So let us look at first how we can be able to solve this before we proceed to the next one. Now we are having the first part and the second part, and you can be able to clearly see that the first part involves using both laws, that is both the multiplication law and the division law of indices. Now for us to be able to solve this, we can solve the numerator first, then followed by the denominator. So in this case, we multiply these constants, which is 9 by 4. 9 by 4 will give us 36. So we shall have 36. Then the factors here are m and n, which are under multiplication. That means we are going to add these particular powers of m and n. So when there's no power, that means there is raised to power 1. So this shall be 5 plus 1. Then for n, we have 2 and 3. That means we add 2 the powers 2 and 3. Divided by, this is 12. The factors are mn. This is like raised to power 1, raised to power 1. Therefore, for us to get the new powers after multiplying, we add the powers of m, which is 1 plus 4. And we add the powers of n, which is 1 plus 2. All this multiplied by m cubed n squared all over 2m squared n. So when we simplify this first part, 36 divided by 12 is going to give us 3. So we shall have 3, then m raised to 6, n raised to 5 all over m raised to 5, n raised to 3. This multiplied by m raised to 3, n raised to 2 all over 2m squared. That's like n raised to 1. So when we proceed, we can again multiply this through. And when we multiply again the numerator, that means we're going to add the powers of m and the powers of n. And this shall give us 3, because it is constant, like 3 times 1. So that's just 3. Then m, 6 plus 3, n, 5 plus 2, over, now again we multiply using the multiplicative law, the denominator. We only have m and n, so there is, yes, like the coefficient of the first part is 1. So 1 times 2 is 2. Then m raised to 5, m raised to 2, we are going to add the powers. That will be 5 plus 2. Then n shall be raised, that is 3 plus 1, which is going to be 4. 3 plus 1. So when we make the simplification, this shall be 3, m raised to 9, n raised to 7 over 2, m raised to 7, n raised to 4. That is not the correct answer because you have not cancelled out the numerator and the denominator. So we now proceed to divide the numerator over the denominator. So this will result to 3 over 2 into the only two factors m and n. Then we're dividing m raised to 9 by m raised to 7. So this will give us 9 minus 7. Then n, it is n raised to 7 divided by n raised to 4. So we again subtract the powers, which is 7 minus 4. This shall result to 3 over 2, m raised to 9 minus 7 is 2, 7 minus 4 is 3. So you find that it is, yes, quite engaging, but at the end of the day it is very interesting to see how they cancel off using the two laws of multiplication and division. But want to see part B of this question. We have 4p raised to a multiplied by 5q. Q has been raised to the power of b over 20q, and q has been raised to the power of 5. Now realize that for us to be able to simplify this, then you should be very careful. Yes, there is division and there is also multiplication. But if you look at the first part, which requires us to multiply, you will discover that only these coefficients of P and Q are multipliable factors. Therefore, you can be able to multiply 4 by 5. Then this is multiplied by P raised to A multiplied by Q raised to B over, we have 20Q raised to the power of 5. Now, because the factors of P and these two factors P and Q are not the same, then we cannot just proceed or go ahead and add the powers. So this shall give us 20P raised to A, Q raised to B, all over 20Q raised to 5. This 20 and 20 are going to cancel off. Then we have got same factors of Q. The first one is raised to B, the other one is raised to 5. And then the rule there is division. Therefore, we're going to use division rule for us to be able to solve the part involving Q. But P will remain as P raised to A. We multiply by Q raised to B divided by Q raised to 5. We subtract the powers because the bases are the same. So this shall be Q raised to B subtract 5. And this will be our simplified expression. We leave it at that because you cannot subtract 5 from a polynomial D. And again, we cannot add the powers of P and Q because P and Q are not the same factors. Example 6, we are told that if M and N are positive integers, understand that integers are both, an integer is a positive, negative, or a zero number, but here we are restricted to positive numbers, integers. How many combinations of M and N satisfy the following? We have two scenarios. Number one, A raised to M multiplied by A raised to N should give us A raised to 8. And again, A raised to M multiplied by A raised to N is equals to A raised to 16. So we are going to basically use the multiplication law because both of them involve multiplication. Then we understand that whenever we multiply, then we add the powers. And in this case, we are supposed to find the combinations of M and N that will give us the resultant power, which is 8. The combination of the positive integers for M and N that will give us the value of positive integer 16. So that is M plus N should give us 8 in the first case. So there are so many combinations. We can begin with 1. Let's say that this is M, then that is N. So we can begin with 1, 2, 3, 4, 5, 6, 7, 8. So when M is 1, for us to have 8, that means N should be 7. For 2 to add up to 8, that means this should be 6, this should be 5, this should be 4, this should be 3, this should be 2, this should be 1, and that is 0. So how many are these combinations? 1, 2, 3, 4, 5, 6, 7, 8. But this is not the end. We can also have the reverse of this, so that we have m and n. Then we began when this is 8. So 7, when that is 7, 6, 5, that is the values of m are swapping or interchanging. 5, 4, 3, 2, 1. So we need to add 0, we need to add 1, 2, 3, 4, 5, 6, 7. So how many are now those combinations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we can be able to say that there are 16 combinations. 16 combinations, which can be able to give us the values of m and n that when added we are going to get 8. Now for this, now there's no need for us to go through all that process. So that simply means that you take the power that you have and you simply multiply it by 2. So like in this case, when the resultant power is 16, this will tell you that we are going to have 16 by 2 possible combination. 16 by 2 is 32. So we can have 32 combinations for this case. Example 7. Show your working. Show working to prove that these expressions, there are two expressions here, simplify to AB, or the resultant is going to be AB. The first one, we have 5a squared b raised to 7 all over 9 a cubed b. The whole of this is being multiplied by 9 a raised to 4 b raised to 2. All of this divided by 5a squared b raised to 7. So I want to show that at the end of working and trying to simplify these, both using the multiplication law and the division law, that we are going to have the result as AB. The first to easily work out is those constant terms, like we have 5, 9, 9, 5. So you can be able to see that this, because we are dealing with multiplication and division, they comfortably cancel out. Then for the numerator, we have got two factors, a and b. A squared multiplied by a raised to 4, we add the powers using the multiplication law, so that shall be 2 plus 4. Then for b, we have b raised to 7 multiplied by b raised to 2. Again, we add the powers, which will give us 7 plus 2. Then over the numerator, we again have the two factors a and b. A raised to 3 multiplied by a raised to 2. We shall add the powers, that will be 3 plus 2. Then b, this is like b raised to 1 multiplied, b raised to 1 multiplied by b raised to 7. This shall be 1 plus 7. So when we simplify the numerator, we shall have a raised to 2 plus that is 6. 7 plus 2 is 9 over a raised to 5 b raised to 8. Then when you finally simplify, a raised to 6 is being divided by a raised to 5. So this shall give us a raised to 6 subtract 5 multiplied by b raised to 9 subtract 8, which shall give us simply a raised to 1, b raised to 1, which is simplified as ab. And therefore, we have been able to show that actually when we simplify the whole of this expression, the result will be ab as was expected. Lastly, number b. We have 2a over 3a squared b cubed. All of this being multiplied by 9a raised to 4 b raised to 7. All of this divided by ab raised to 5. Then the whole process we divide it by 6a all over b squared. So there are two ways of working out this one. The first way, we can decide to dance around this particular sign here, where we are having positive division or divided by 6a all over b squared, so that we multiply and we find the reciprocal. Or still, we can be able to work out this, then we proceed to the other side. So let's first work out this using the law of using the law of multiplication. So this 2 times 9 shall give us 18. A raised to 1 multiplied by a raised to 4. We shall add the powers, 1 plus 4, which shall give us 5. Then we have b raised to 7 over, we have 3, a raised to 2, a raised to 1. This shall give us a raised to 2 plus 1, which will be 3. B raised to 3 multiplied by b raised to 5. This shall give us b raised to 8. Then the whole of this is divided by 6a all over b squared. 3 here once, 3 goes into 18 6 times. Then if we decide to solve this other part, we are going to have 6 a raised to 5 b raised to 7 over a cubed b raised to 8. We find the reciprocal, we change the sign and we find the reciprocal. That will be b squared all over 6a. So when we finally solve that, this shall be 6 a raised to 5. The powers we add 7 plus 2, which will give us 9 all over, this is 6. A is raised to 3, a is raised to 1, so this shall be a raised to 4, b raised to 8. So these and these will cancel off, and we're going to remain with a raised to 5, b raised to 9, divided by a raised to 4, b raised to 8, where we now apply the division law, where we subtract the powers, and this is going to give us a raised to 5 subtract 4 multiplied by b raised to 9 subtract 8, which will give us a raised to 1 b raised to 1, which can be simplified as a b. You can try this assignment where we were told, given that a is equals to 2x and that b is equals to 4x squared, and that c is equals to 5x cubed. Find expressions for one, 2a, b, negative 2a, c, negative 2bc, all over a, then finally d, c over b. So you can try working out this. So this brings us to the end of the discussion on the laws of multiplication and the law of division, where we have said that the law of multiplication, when you have a raised to m multiplied by a raised to n, this shall be a raised to the sum of the powers. And then for the division law, when you have a raised to m divided by a raised to n, then you get the difference of the powers, which will give you a raised to m minus n. So that is it. Next time when we meet, we are going to look at the zero index and the power of a power. Thank you.